Okay, today is called factoring using synthetic division. But why does it say long division on the top of the page then? Because I want to remind you about long division first because these are related. This is the same thing as we did yesterday. It wasn't super easy. I'm going to help you with this one. Everybody put the dividend in the den. Remember which one that is? False. The bigger one. 2x to the third minus 9x squared plus 25. And then on the outside, 2x minus 5. Now last hour I went with a different technique. I had them go until they got stuck and then showed them why they were getting stuck. I think I'm not going to do that because it caused a bunch of confusion. So I'm going to tell you there's something different about this problem than any one we ever did before. Can anybody figure out what's different? It's kind of that game, one of these things is not like the others. What's different now? 3 of you have caught it. I want more of you to catch it, so I'm going to give a little more time. It's called wait time. Come on, what's different? Raise your hand. Be proud you figured it out. Miss B? All right, so there's like a, you said a coefficient on the variable. You're absolutely right. There's a 2 there. I don't know if we ever had that before. Very good. But there's something else that's different than we've ever done before. It's not that there's perfect squares in it, like a 9 and a 25. You're right that that's notable, but that's not the thing I'm looking for. I know this is kind of that read my teacher's mind thing, but let's try to think of anything that's different about this than we've ever done. Mr. C. Yes, there's an x to the third, there's an x to the second, but there's no x to the first. That's going to cause a problem. Do you remember in elementary school when they were like having placeholders? And it was like you needed this placeholder number? I'm going to show you an example of that. If I go 27 times 3, do you get that that's not how you do it? You got to move the 3 over to here. Know what I'm talking about? And then when you're multiplying out 27 times 3, actually, let me make it 27 times 13. 3 times 7 is 21. 3 times 2 is 6, plus 2 more makes 8, 81. And then at this magical moment, you needed a placeholder. Do you remember where that placeholder goes? Underneath the 1. And then you go 1 times 7 is 7. 1 times 2 is 2. And that gets you a bigger number than it would have been because you moved everything over with that placeholder 0. There's other times in math you need a placeholder. This is one of those times. Do you get, since there's no x to the firsts, I could move this over, and I'm not lying when I say there's 0x to the firsts. Get what I'm saying? Plus 25. That's the same exact thing as it was before because I'm just saying, I'm writing that there are 0x to the firsts. Why do I do that? Because if you don't, things won't line up nice. Later in the problem, you get stuck, and then it confused a lot of people. So, all right, so on a problem like this, you got to watch out for a placeholder. That is absolutely the kind of thing we would test you on. So it's not just like a weird, that never happens thing. Got to be prepared for placeholders. Okay, so if it doesn't go down nice, 3, 2, 1, 0, or 4, 3, 2, 1, 0, if it ever goes like 3, 2, 0, so then, wait a minute, where's the x squared, you know? Yes? It can be done, but it won't do it. It won't happen with long division. So since we're showing long division here, okay, I understand you can fight your way through it without the placeholder, but I'll show you why. You'll understand why you'll need the placeholder when you see this, okay? All right, so if I start this problem, do you remember me saying where you always start? Up here, and you put what right there? An x. And if that doesn't work, you try something else. This x wouldn't work. How do I know? Because x times 2x is 2x squared, and that didn't work. So what should it be? X cubed, I'll try that. X times, that's going to be 2x to the fourth. Oops, that's too big. So now what? X squared. There we go. Everybody put that one up there and then multiply it out. Times both pieces, that, and then write it on your iPad. Okay, so that x squared multiplied out. Miss S, tell me what to do. And I get? Yep. Is it nice that that matched up with that? Yes, that's super important. If that didn't match up, we'd have to start over again and try something else. Okay, keep going. Minus 5x squared. Good. Now that is perfect. What is the next step? Keep going. That becomes negative. That becomes positive. Very good. All right, Mr. Z, take it over from there.
So then you have, so it's those two cross out, those two.
Perfect.
And then negative 9x squared plus 5x squared, that makes negative 4.
Perfect. Negative 4x squared. Mr. V, tell me what to do now. Nope. Because that's what would get this messed up. Because do you get, if I bring that 25 down, I don't have any x's. Let me just show you what would happen if I did bring down the 25. If I did bring down that 25 and I've just skipped over the 0x, then when I stick a negative 2x here, it won't work. Negative 2x times positive 2x makes negative 4x squared. That worked. But negative 2x times negative 5 makes positive 10x. And those, how are you supposed to add those together? They aren't even like terms. Do you understand why I can't do it without the placeholder? All right, so anyway, I'm sure that there's a way around it, but the way around it I'm teaching you is to have a placeholder right there. That's what we bring down. Bring down the 0x. Oh, wait, no line yet. Okay, so now I put my negative 2x up here. And I have negative 2x times 2x makes negative 4x squared. And negative 2x times negative 5 makes positive 10x. Now here's a classic case. I'm going to make a mistake on purpose to show you what I'm doing wrong. Okay, these two cancel and the answer is 10x. What did I do wrong? Didn't switch the signs. You got to switch this from negative to positive and this from positive to negative. So it's negative 10x. You got to always switch those signs. Okay, Mr. R, take it over from there. You actually, Mr. R. I'm sorry, there's two Mr. R's. I'm going to go with the green one for now. I'll finish up with the dark blue one. Okay, bringing down the 25. And a negative 5 up here. Negative 5 times 2x makes negative 10x. It matches up, so I know I'm doing it right. And negative 5 times negative 5 is positive 25. If those are exactly the same, then they're going to cancel, and the answer will be 0 at the end. Do you get how if there's no remainder at the end, that's a good thing? All right, so then you got your answer. 2x minus 5, x squared minus 2x minus 5. All right. Any questions? That's called long division, and you mastered that yesterday. So, synthetic. Synthetic division is the new thing that you need to learn right now, and this is not, it's not incredibly hard, but it's a lot like using long, and I'm going to show you, kind of like yesterday I showed you how to make normal numbers do long division, and then I moved to showing you how to make the variables do long division. Now I'm going to say, well, if we were doing it with long division, I would stick a 2x here. And if we're doing it with synthetic, we'll do this other thing. Okay? So let's start by just solving the problem on the left using long division. But everybody just make sure you show your work. Solve the problem on the left using long division. Show all your work in here and stuff. I'm going to pair you with somebody. and see if you can check with them to see if you're doing it right. All right, so here we go. You put a 2x on the top like I did, you'd have 2x squared, and then this gets multiplied by the -3, -6x. Draw the line. Remember, important step, opposite, opposite. And then you get, that will make you 5x. Bring this down, -15. Then I go, what do I put in for to make a 5x? A plus 5. 5 times x, 5x. 5 times the -3, -15. Those match perfect. I get 0 at the end. It worked. Raise your hand if you had that one right. Cool. Now, I'm going to show you synthetic. Synthetic is where you take the numbers. Let me show you where I get the numbers from here. Take just the numbers. Notice there will not be a single variable. That's kind of cool. You strip all the numbers off and get rid of the letters. This becomes a +3. Why +3? Because it's the 0 for that factor. It's the root for that factor. Do you get how that's the thing that would make that factor 0? All right. Next, take a guess what numbers I'm going to write here, here, and here. 2, -1, and -15. I got those. Those are the coefficients right out of my equation. 2, there's a -1 right there, even if you can't see it, and -15. Okay. Now what? Now you do the Snoop Dogg song. Don't worry, I'm not going to play the whole thing. Okay, so we have the 2 drops down just like Snoop Dogg would tell us. And now here's the next part. It's multiply, then add, multiply, then add, multiply, then add. So it goes really fast once you're used to it. Really, it does. But watch me do it first. 2 times the 3 makes 6. Then I add these two. -1 and -6 makes 5. Then I multiply again. 5 times what? 3. 5 times 3 makes 15, and I put it here. You see what's going to happen here? And then I add them straight down, and what do I get? 0. And guess what? If you end with 0, it worked. Just like on the other kind, if you end with a 0, there's no remainder, and it worked. Okay, so this cryptic little thing is way faster, and I will guarantee you when you have like a 5-part factoring to do, that you would much rather do synthetic than long. Long division takes a long time. Synthetic's really quick. Okay, so you get used to this and you'll be like, oh, can I please do synthetic? And it'll almost always be yes, you can do synthetic. There's a couple problems though that you'll see when we come to the test that you have to know long for. Like you can't do it with synthetic. It won't work. But anyway, and it'll be obvious because you'll try it and you'll be like, how, I can't even put a number in for synthetic. It won't work. I'll show you. If it was like x squared minus 3 here, you have no number you can put right there. So you couldn't do it with synthetic if there was an x squared minus 3. So anyway, on most of them though, it will work. Synthetic will be awesome. Now why do I care that all these, weird numbers in these weird places, what does it really mean? The answer is, bring this down here, make a parenthesis for it, and remember how that came from a factor? What was the factor again? X minus 3. And then this makes the other factor. And see if you can figure out, what predictions, what it's going to be? 2x plus 5. There it is. It's factored. See how fast that is? I know I took a long time to do it because I was showing you for the first time. But I'm telling you, I can do a synthetic in like literally 20 seconds. I can have a synthetic problem done. Yes?
So do you know it's going to be x plus 5, or 2x plus 5 because we already did it in long division?
Yeah, but you're not going to do it with long and synthetic.
Great. How do you know?
Well, how do you know if it really worked? Good question. If this is really the right answer, you should be able to multiply it back out, and it should come out to this. Get what I'm saying? All right, that's how you can tell if it works. Foil it back out. First outside and last. Okay, so let's move on. Here's another one. It's orange. Don't see orange backgrounds that often. Enjoy it while it's here. Okay. So let's not even do long this time. Let's jump right over to synthetic. I think you'll find that it goes way quicker. What should I put in the little box, the first little box there? -4. And then what 3 numbers do I put on the right? Excellent. Then take some advice from the dog, as I affectionately call him, and drop it like it's hot. Then 1 times -4 is -4. That's a multiply. See if you can do the rest. If it comes out to 0, you know it worked. Then don't just leave a cryptic set of like 7 numbers on your page. Write me the 2 factors. If you really get what's going on, you should be able to tell me what does it factor to. All right, so this one made -7 when I add them straight down. And then -7 times the -4 makes +28. Add them, I get a 0. Yay, it worked. Then I got to translate. This means x plus 4. Anybody get fooled into thinking x minus 4? It's easy to do. But remember, -4 solves it, makes it equal 0. So that's why this has to be an x plus 4. And then this one is just 1x minus 7. Raise your hand if you had it right. Good. See how much easier that is? All right. I think you want to use that most of the time. But like I said, you'll have to know long. A couple problems on there only can be done with long division. All right. Use synthetic. Let's see if you can do it. This time, by the way, hint, hint, they didn't give you a factor. They gave you the root. So you use the -8 in your synthetic. Don't change it to +8. Because they didn't give you a parenthesis, x plus 8 or something like that. They just told you the root right off the bat. See if you can do synthetic. Okay, we got a -8 there. And we've got a 2 and a 10 and a -46. Do you think that same thing would hold where if we had a missing term, we'd have to have a placeholder? Yes, it would. So if there was like no x's in this equation, there was only x squareds and like a number, you'd have to say 0 x's. And you'd have to have a placeholder 0 in here. If there wasn't a 10, because like this didn't exist, you'd have to put in a placeholder 0 there instead. But again, if you try it once without it, it just won't work. The last numbers won't line up, and it won't end up being equal to 0 like it's supposed to. So you can try it yourself, or you can trust me. If you have a missing term, you have to have a 0 placeholder in one of these spots. Otherwise, it won't line up. All right, so then you dropped it like it's hot, and then you got 2 times -8, -16, and then you added, makes -6, and you multiply, and that makes 6 times 8 is 48, +48. Is that right? Oh, so it didn't work. Is that okay? Yeah, it's okay. So what's the answer to the question? No. Is that a solution? No, it's not. If it had come out perfect, like it was a 46, then you'd be able to say, oh, I guess it worked, and my answer was x plus 8, actually, and 2x minus 6. But it didn't work because we didn't have a perfect 0 at the end. We had a 2. So it had a remainder of 2. All right. If I really wanted to extend this, I would be able to tell you, and I'm going to hold on for the people that are like super bored because this has been so easy. This would have been x plus 8. This would have been 2x minus 6. And that is a remainder, and so it would be x plus 8, 2x minus 6, and the remainder, which is the 2, would be 2 over x plus 8. And then if you multiplied those all together, it would equal this. But you don't have to know how to do that. I just wanted to throw it in there to prove I'm smart. And to help the kids in here who are a little bored be like, oh, I see how that could work. All right, let's move on. This one. Use synthetic division. You can do it. It doesn't even need placeholders. This one's a fairly easy one. And think about it. You would not be factoring this one in your head. There's no way. But with synthetic, you could. I'll pause for a second while you give this one a shot. Okay, so when you put in a -2 right here, and then you put a 3, a 4, a -3, a 1, and a -2 across like this, and you drop it like it's hot, and you multiply, and you add, and you multiply, and you add, and you multiply, and you add, and you multiply. It works. Look at that. Raise your hand if you had that one right. Okay, good. Then, what is the actual answer factored completely? Well, this part tells me to put what? X plus 2. And this part says I have, can I just slap an X on this one and have all those other numbers? That doesn't make any sense, does it? So think about it. Which one of these do you think is going to be the X? The 3, the -2, the 1, or the -1? Nope, the 3 is not the X. The 1 is the X. And what do you think the -2 is? You are correct. The -2 is the X squareds. And then logically, the 3 must be the X to the thirds. So here's my other parenthesis. There, you just factored a really big, scary one. Notice there's nothing in front of this 1, so I'm putting a plus. That means it's positive 1x. So 3x to the third minus 2x squared plus 1x minus 1. All right. Now, did anybody even think about how this is a 4-part problem and therefore could be factored with divide and conquer maybe? Just watch out for that, because that's where we're going next. Is you get it factored using this synthetic, but then you can factor it again with divide and conquer. And then you can factor it again when you see something like x squared minus 9 in it, and you can make like x plus 3 and x minus 3. So you have to use all your factoring genius on one problem. That's where we're moving to eventually. All right, so for tonight's homework, I'm going to ask you to do, again, the even problems and even letters. If an even letter requires you to end up having to do the whole problem over again, then you don't have to do that one. Okay? But even problems, even letters for your homework for tonight. I will get those 2 scores from you that we just graded in class. I'll ask you for those scores tomorrow because we're down to 2 minutes and that's not enough time to get them. So, all right, that's all I got for you for today.